So, thank you everybody for coming, a huge crowd today. So, I'm Luciano, and you can find me on Twitter as Loige or on GitHub as El Mammino. I also have a blog, and I am the co-author of this book here about Node.js and design pattern, together with a guy that should be there. So, if you like the book, please go and tell me. If you don't like it, complain with that guy. So, this guy here is Podge, great guy, by the way. And he is also on Twitter. He doesn't have a book, at least yet, but he's the organizer of Node School Dublin and Node School Dunleary. Actually, he's going to host the Node School Dublin in 2 weeks, if somebody of you is interested in learning Node.js. And he's also the organizer of an upcoming meetup about serverless, which is Dublin Serverless Meetup. And big news, he's writing his own database, so might be a bit crazy, but it's a nice stuff. So today we are going to have a talk of about 40-50 minutes. I hope it's not boring, but we are going to cover more or less these topics. So what is Planet 9 energy? What is serverless and how we use serverless? And then some topics like how would you do security or quality or care about developer experience when you are dealing with a serverless architecture? And then how can you predict your costs? And some lessons that we learned along the way in this 1 year now that we are dealing with serverless. So I'm going to leave the rest to Podge. I got my own thing.
So my voice is very loud, so I'm going to experiment with a fairly simple switch word. So Planet 9 is a startup and a spin-out of the ESB, it's our parent company. We're based out of Dogpatch Labs. We are going about 7 months now. And we are trying to provide electricity to small to medium-sized businesses in the UK. The two selling points that we're always trying to hammer home to our clients are: one, we want you to be able to see your bill transparently, which is a big problem actually in the UK because everybody gets is a monthly bill for 200 grand, pay your bill, and they have no idea the breakdown of where that money actually goes. So one of the things we want to do is show some transparency. We have a lovely, beautiful UI here built by one of our developers, Peter, who's in the crowd. The second thing we want to do is, if you look at the bottom left-hand corner, there's like a split between energy and non-energy. So you get charged for actual electricity, and there's a whole raft of other charges that you get charged as well, that are for regulatory reasons. The energy side is pre-bought, so 12 months out, you have to buy all your energy. We want to allow people to basically trade it on a daily basis, automatically through an artificial intelligence. That's what we're going to go with, but it's kind of like that. So they're the two things we're always trying to get across what we're trying to do. The kind of problem that we have is the amount of data that we suck in. So there's meter readings are done every half hour in the UK. There's, if you're good at math, 17,520 half hours in a year by the number of meters that a customer of ours would have. Our customers are split into 3 tiers of consumption. So there's 1,000 companies that consume 1/3 of all energy in the UK. There's another 50,000, I'm looking at someone here, 50,000, yeah, 50,000 in the next tier down. That's who we're trying to chase. And the bottom tier is 29 million residential households who we'll get to eventually. So for us, the size of our problem with the amount of customers that we're trying to target with the amount of data that we're trying to do is about 4 billion data points. So why I'm saying this will come in later on at the very end. Just keep that number in your head. When we started 6 or 7 months ago, it was just me and Hugh, CTO, who's drinking beer. We sat down and we said we want to set out a bunch of requirements. So we want to be the ESP, we want to get out of the way of their way of thinking. So we said we want to hire a bunch of engineers that can do everything. What that really means is we want a T-profile of engineers. They're really good at one thing, but they want to do front end or they want to do APIs. Or in my case, my core is databases, but I want to do APIs. So you have that kind of thing with a T-profile. We want to deploy quality code as fast as possible, which Luciano will talk about with our CI pipeline, and him and Peter Bothfield, again, who's in the crowd, did. And we want to do hot and relevant technologies. I did not write that line. Yeah, but we want to be on the bleeding edge, so we chose serverless as a concept and as an implementation detail. We also chose stuff like React and Redux. I'm struggling. The main thing we didn't want to have to manage infrastructure if we could help it. We don't want to get called at 2 AM when the server dies and doesn't recover. And it has led us to some of our early experiments to see what that would be like. So we started with Windows Azure because that's what we inherited from the ESB. And we had 100 grand worth of free credit, and we still sit now. It was fine. They didn't have their cloud functions at the time. It wasn't even in beta or preview with them. So like they were completely not at the races for what we wanted to do. We tried JAWS, which is depending on who you talk to, was JavaScript in AWS or just AWS. I go with just AWS. The other one we tried was Dynamo. We didn't like Dynamo. I know Intercom love it. We didn't. It was very unpredictable to predict our throughput. So if you didn't know what your throughput was, you'd have to reserve a lot of writes and reads, which is very expensive over time. We used and are still using Redshift. Some of the use cases we did, like we tried to build an API directly off the back of Redshift, and that does not work. We tried, and I'm going to need help with TJ. I can't pronounce his name. He wrote a similar framework to Serverless, which is Apex. Apex uses a thing called Terraform for its orchestration, which none of us knew, and it's found out to be a very, very high learning curve. We got to experiment with all this stuff over a couple of months, obviously, but a lot of it got binned because of the reasons I mentioned. Either didn't work, didn't scale, cost too much, or in Apex's case, no one's really adding to the code base other than TJ, so you get like one release a month, or one commit a month in some cases. This is what we eventually landed on, which is the serverless framework in Node.js using React, and I always get this wrong. It is API gateway with lambdas, going to RDS with our React hosted on S3, and we use Squish and SQS and SNS to pass messages around. So that's where we are pretty much today for most of our back-end and front-end work. Serverless has many meanings to many people. There is no such thing as serverless. It just means there is a server there somewhere in the background, obviously. It just means we're not managing it. In our case, it's AWS manage it for us. Continuing on, it's also a framework, so it's a methodology or a concept, but there is the serverless framework as well, so naming things is hard, right? We use Serverless, which used to be JAWS, and we found that it has taken away a lot of responsibility for what we do in a good way. So we don't have to learn too much about CloudFormation, which is the orchestration tool that's used. We don't have to manage the automatically zipping up of your code and manually going to AWS console and uploading it manually and then doing all the other steps you need to get a Lambda connected up to an API gateway. Pretty much Serverless does all of the framework, does all of that to you, for you, purchase English. So that was why Serverless the framework. This is what it would look like. We had a debate on whether we would go through this today, and I'm probably not going to go through it in detail. You want me to go through it? No. Okay. Give me a request. Basically, the backbone of the service framework is its YAML file, and you basically describe the entire service through this YAML file, and then you write your Lambda actually in Node locally. This basically just describes it. The big one is the provider is AWS. Technically you can do Azure and you technically can do Google, but you can't. It's like a future thing. So if you do it, it actually just won't work. Austin Collins says the Azure stuff, the guy who makes service, that the Azure stuff is coming in like the next month or two, I believe. When you're describing, this is just a continuation of the YAML. So only use case will do tonight, and you can have like 10 different use cases for this YAML, is we want to concentrate on this guy here, which is the HTTP event, which is basically API gateway. So an API. This is the resources. It's a get method, core is set to true. This is your authorizer, which you're going to talk about. That's pretty much all I'm going to do at the moment with Serverless. It would be too dense a subject, and we have 40 minutes to talk about it. We will be probably maybe doing a workshop on it at some stage if you want to get involved in that, or at Node School in 2 weeks. We chose Amazon because they were the only guys at the races. At the time we chose them, they were the only ones who had Lambdas implemented. They've been around for about 2 years. Azure didn't have function, or what do they call the ones now in Azure? Functions. And Cloud and Google have their own one as well, and that was kind of finicky because, well, they had functions, they have nothing else in that stack that we wanted. So that's pretty much why we chose AWS. I love this guy down the bottom right corner, Lambda. That joke, we'll laugh. So what is a Lambda? It is a function as a service. It is a cool thing where you just write code, write the function, and you deploy it to AWS. An amazing thing if you're worried about costs is that you only pay for the time that it's actually running. So if you spin up an EC2 instance and it's a micro instance, you're not on a free tier, how much does it cost you a month? Does anyone know? About $100. And if you're doing nothing with it, it's still costing you $100. So when you deploy Lambda, if you don't execute it, you don't get charged for it. Virtually infinite auto-scaling, and it should be infinite. I will talk about soft limits later on. You have an initial default limit of 100, and we find out some of these soft limits the hard way, and we'll talk about them later on. But yeah, it technically is completely infinite out to like 100,000 calls if you wanted to. And it allows us just to focus on writing code for our customers and not worry about orchestration. So that's kind of why we chose Lambdas. This wasn't really written by me, it was written by Luciano. So everything in Lambdas, everything in a Lambda has an event, and it is the trigger that starts off the execution. You can have different events like HTTP. You can have events like HTTP, SNS, Dynamo, S3. So if you put a file into an S3 bucket, it will fire an event that will get passed into a Lambda if you've configured it like that. Every Lambda scales independently. So it's like a sandbox. Tim Wanger does a great blog post on how they did it, and basically if you do a monolith type of an application, there's always that propensity that I can just go and take something from over here and I'll use it over here and it won't cause me problems later on. With Lambdas, there is no, I can't just directly access another Lambda, or I can go directly over here to do something. It just is completely sandboxed off and won't let you do that. Agility. So develop features quick and in a nice little fashion. It goes back to the previous point about, again, you can't just reach over and get something. It is sandboxed all the way. We talk a lot about granularity and orchestration, so it's the similar always with microservices, and where's the boundary for every service we create, where's the boundary for every function we create. We talked about it for 2 hours yesterday. It's great. You do get other problems as well, like services. There is no service discovery for us. We kind of have to know where our stuff is right now, which isn't great. So it's all not peaches and cream with them. This is a basic Lambda. It is the most basic one you can do. It always takes 3 things: an event, the context, and the callback. An event is what I just described, so no, it's not on the next slide. An event could be your API gateway call, and it will have key value pairs in a JSON object that describes what happened. And we do have an example in 2 slides of that. Context has methods and properties of what is happening with the Lambda. The only method I can ever remember is the countdown method, which is how many milliseconds you have left in your Lambda. And a callback is a normal callback returning control back to your client. These are some of the use cases. So we talked about the REST over HTTP one. It's the only one we ever show you. You can do SNS, you can do cron jobs. If you insert something into DynamoDB, you will get data. A Lambda will fire off it, and you can pass the data that was inserted to the Lambda. Similar for S3, if you pass a file, you can process the file. IoT is there, but I've never looked at it. This is an example of an actual event. So Luciano is really good at doing visuals because he wrote a book. This is the path you have here. So it's hello, Elvis, foo bar, and testing body. All of this will be broken down a few automatically by AWS. So there's the post. Path parameters is what we use, and it breaks down name, Elvis. Love the name. Where's testing body to the top? So there's your body. So it will always be the same if you use the default integration of the API gateway. You can write your own events as well if you want. Do not do that, you will regret it.
Okay, so I'm going to jump to security. And the idea is that, of course, security is a huge topic, but we want to see how thinking about security is going to affect your experience with serverless and with AWS Lambda. So we are going to talk specifically about how we are going to manage something like authentication and authorization, and also how can you manage sensitive data. Probably there will be hundreds of valid solutions to this problem, so we're going to try just to describe the solution we found. So regarding authentication, basically the questions we want to answer is, who is the current user? So we get a request or an event, if we want to call it this way. Is there a user behind it that we should know? So to manage this problem, what we use is an external tool called auth0, which you are probably already familiar with. And this tool makes a very heavy use of JWT tokens. And also we use another feature that is already in AWS called Custom Authorizer Lambda. So I'm going to show you a very quick diagram to explain how this thing works. So basically we have a user here in the bottom corner that tries to authenticate himself against our front-end application, basically sending username and password through a form. What happens is that our front-end is going to call the auth0 APIs just to verify these credentials. If everything is okay, auth0 gives us back a JWT token. And we can use later on, so this token gets stored into the local storage of the front-end application, and for every other API call that we do to our services, we just need to attach the token there. What happens is that for every API call that requires authentication, we just intercept it using this authorizer function. What is really this authorizer function? Really is a lambda. It's a special lambda that inside just need to do one thing. Check if the token is valid and if it's associated with a valid user. If that's the case, we just propagate the call to whatever lambda needs to be invoked together with the user ID. Of course, if the token is not valid anymore, we just reject the call and we show an unauthorized error. So basically, the authorizer is nothing else than a middleware. Moving on to authorization, the problem that we want to solve, or the kind of problems that we want to solve, is something like, can Podge trade for account number 23? Or if we want to put it in a more generic fashion, is, can a user do a specific action on a resource? Again, there are probably many solutions to this problem. What we wanted to do is to have a very easy way that just allows us to write as less code as possible. So we came up with our own custom ACL library, which is at the end implemented on top of two very famous libraries like Node.js or Knex. And the idea is that we have a very simple table in a Postgres database that just lists users, actions, and resources. And basically means if we have a record, we are authorizing somebody to do an action on a resource. Like in this case, we have Podge can trade on account 23, and Luciano can delete everything, just for fun.
And he has.
You were not mentioned to say that. Anyway, so just to show you how the code is concise with this approach, we just need to import a library. You can see there in the top, actually just a function from this library that is called can, and then we say, is authorized is equal to, can these users do an action, in this case trade, with a resource, in this case a specific account. And this value at the end can be true or false, and if it's false, we just need to throw an error to stop the execution of the lambda. So this is going to be most likely the first thing that we do in every lambda. Moving on to another topic, how do we manage sensitive data? Which basically means you don't want, of course, to publish sensitive data like username and passwords in your repository. So you don't want to hard code them in your JavaScript code. So how can you manage this in a regular Node.js application? Basically, one solution will be using environment variables. And you can do pretty much the same thing with lambdas and AWS. From a local development point of view, you just need to create your variable. So you're going to say export, in this case, a connection string. And then in your code, you will just access to process.env.connection string. Then the next issue is, okay, I did this locally, it works. Now, how can I publish this variable online in my AWS account? And Serverless, the Serverless framework, helps us with that. And basically, you just need to enter a configuration. So for every function, you will have a map called environment. And in this map, you just need to list key and values. The cool thing about this is that the value actually can be an expression. And in this case, we are referencing a local environment variable in the current machine, which means in the moment you are going to deploy the Lambda from that machine, we are going to copy the connection string that is available in the machine itself. So basically, we have a deploy machine that knows all our environment variables, and that's the machine we use to do deploys. But no developers know what is the password for production, for example. And this is how the variable will look like when you will enter into the AWS dashboard. So basically, we'll have connection string equal whatever is the variable. And then you will see, okay, but this is still clear text. It's not in my repository, but it's in the Lambda dashboard. There is, of course, another level of security, which is enable encryption helpers, which allows you to use a KMS key to keep this value encrypted there in dashboard as well. So you can use all these levels and be sure that only the people that need to have access to sensitive data will do that and nobody else. And at the same time, you are not compromising the developer experience. So moving on to another topic, quality. I want to discuss how do we do testing, because it's not that easy as it might seem. And also the continuous integration pipeline that we came up with to simplify our development and deployment process. So testing, of course, we have two levels of testing, having a backend and a front-end app. For our front-end, we use Jest because it's the default testing framework that you would use for a React application, but I'm not going to talk much about this. And of course, we have two front-end guys here, so if you have any question, I can tell you who they are. But moving on to the backend, we use Node.js, just because it's the simplest testing framework, and we don't need that much complexity for testing a Lambda, which basically is just a function most of the time. So how do we do unit testing? This part actually is very conventional, I would say, because we follow all the regular rules that you will use in any other Node.js application, which are, you need to split your code into small testable units, and in these units you will inject every dependency. So it's going to be very easy to mock things like database, file systems, or other functions that you already tested somewhere else. In our case, to do mocking, we use a library called, I think the pronunciation is Sinon or Sinon, whatever. And of course, we aim to achieve 100% coverage for every Lambda that we write. And we also use the Nyancat test reporter. Not sure, but it's cool. Moving on to functional testing, that's a bit more controversial topic, because the idea is, okay, I want to execute my Lambda in a test environment. So there you start to have a lot of complexity. And the solution we came up with actually is quite simple, I would say, but most of the time works. So basically we just have a tap test that executes our serverless framework locally, run a specific function with a specific event as an input, and then we just make assertion on the output. So I will show you an example in a moment that will make this clear. Then the issue is, okay, we will probably need to recreate some environmental thing like a database locally. And we do that most of the time using Docker. For example, we have a Dockerized image for a test database. The issue is that you cannot always recreate everything locally. For example, Redshift, SNS, SQS. So sometimes you cannot always test everything. Or if you can, you need to recreate your environment online in a dedicated AWS account, which we are not doing so far. So just to show you an example, very easy, just look at line 5. we create a command that we execute with the exec Node.js function, and then we just get the output here at line 11 and 12. We pass the output, which is going to be just a JSON string, and we can do assertion like, okay, given this HTTP request with this input, is the output at 200 okay? And of course, you can do more complex stuff if you need to test other behaviors. Okay, moving on to another interesting topic. We do a build of all our lambdas. It's not required, but it's something that can be useful for different reasons. In our case, we do the build using Webpack and Babel, but the main reason is that Lambda runs, actually I will show you here, in Node 4.3.2, that's the best you can get so far. So there are many features, especially regarding ES 2015 or ES6 if you prefer, that are already there, but not all of them. But of course we want to use all the cool stuff like async await or modules. So what we are doing is basically using Babel with this custom preset to transpile whatever is not in this version of Node. Why do we use Webpack then? Because Webpack has a very nice feature which basically allows us to start from a single file, which in our case is going to be the handler, which contains the main Lambda function, resolve all the dependencies. So in this case you will see internal dependencies in the src folder, but also there are other external dependencies inside the Node modules. And it's gonna just understand whatever you are really using in your Lambda function, extract all the function, and create a single file containing only the things you are really using. This allows us to have very small packages, like we can reduce the code up to 90%. So this allows us to have very small and quick to deploy artifacts. At the same time, in the same build process, we also build the documentation using Swagger and JSDoc. So now I'm going to show you more or less how we make sure that this package gets deployed in every environment. So basically the developer experience looks more or less like this. We use Git flow, which means that for every feature or fix that we need to develop, we create a new branch of a specific repository, and then we just need to publish our code into this branch using GitHub. And when there is a new commit on GitHub, we trigger a build process on CircleCI, which is our tool for continuous integration. And what happens is that CircleCI is going to spawn a container where our code is tested. And the tests are, first of all, we check if all our coding style rules are respected using ESLint. Then we run all the unit tests. If everything is okay, we create a build of the project using Webpack and Babel. And then we run all our functional tests for that Lambda against the build. And also, if the commit is on master, which means that is the result of a code review and it's something that is more or less ready to go into a QA or production environment, we create a deployable artifact that is stored inside CircleCI itself. So basically, we do this local development that triggers as soon as we push a build using CircleCI. Then we still need to move these artifacts into a real environment on AWS. How do we do that? We use a tool called Rundeck, which basically is just a script manager, so allows you to have scripts that you can run from a web interface with just point and click. And our idea is that every time we want to deploy a specific version of a Lambda in an environment, we just go to Rundeck and we select. As you will see here, you say deploy, and then you just select your project, the version of that project, so build number, wait for that, here it goes. Then you select the stage, and then you just hit run job now, which will do everything for you. And this is very handy because one of the issues that you mainly have when dealing with a lot of Lambdas and different environments is that as soon as you start to use the command line to deploy all this stuff with different configuration into different environments, sooner or later you will do some big fuck up. And then you don't even know when you did that. So you will have inconsistent environments everywhere. Also, one of the very nice things about Rundeck is that all your logs are stored there. So you will have a user associated to this execution. You will have a timestamp. So you can actually audit every single deploy. How it works internally is that basically in the first part of the script, we just download the artifact from Circle CI, and then we just run serverless deploy. So we are just making easy to deploy stuff. So that's basically it. I will leave the rest to Podge.
No, you can stay here. We're going to tag team on this one if we can. So local development, debugging, and monitoring. So Serverless have a section on their website, the framework. They have a section on their website where they say develop locally, invoke it locally, deploy to AWS, then invoke it on AWS, and you can stream your logs directly from CloudWatch. Most of the community seems to think that this can take minutes, especially if you're doing like a one-line change. So they kind of have said this is kind of a slow feedback loop, and there's been a lot of requests to improve this, and some of the community has gone out and done their own improving on their own, because Serverless has this concept of plugins, so you can actually extend the Serverless framework for your own nefarious purposes. I'm going to talk about just 3 of them. There's about 50 in total. There's a GitHub repo dedicated to it. My top 3, one will be Serverless offline. So instead of having to upload it to Amazon and testing it through API Gateway in a dedicated AWS account, there's this concept of Serverless offline, which tries to mimic API Gateway. Because it's such a new framework, it has issues. Like with the API or the Serverless offline, the authorizer doesn't work as you would expect, as in it doesn't work at all. There's also stuff to be aware of. So there's another plugin for API Gateway. I hope I copied the right one. And it's got to do with logs. So logs aren't turned on by default in API Gateway, and you have to. It's a very laborious process to try and remember where it is and actually go and do it. There's a plugin where it just gives you add it in, and you just put it into the YAML file like you do with everything else, and you go API Gateway logs, true. And it'll save about 20 minutes every time. Luciano doesn't like this one because it's Mocha, but this is a plugin that it's more like a helper really. So when you spin up a function using SLS create, it actually adds a test folder for you automatically, and it's a Mocha one, and installs Mocha for you as a dependency. And that's pretty much it. There's like 47 other ones there that you can look at. It'd be too much to go through all of them. Monitoring is interesting. So CloudWatch there in the middle. Is there any Amazon people here? Good shit. We don't like it. It's hard. It's clunky. You can tail stuff through the AWS command line. It's just difficult, especially if you're calling multiple lambdas at a given time. You have to go to different places in CloudWatch to get it out. We were probably going to go to New Relic or Datadog, but it has its own problems. You have to install agents. If you have to install an agent, you have to install a server, and we hate servers. We have one server which is Rundeck, and if anyone knows about a hosted Rundeck service, I'd love to know. The one we are kind of playing with the most is Loggly, and this guy in the top right corner, which is a TextAirs company called IOPipe. Loggly. The thing I like about Loggly is that there's no agent needed, so you actually get a Lambda, and whatever deal they've done with AWS, it's actually a blueprint in Lambda. So when you go to spin up a Lambda in AWS, you can pick a blueprint, and Loggly is one of them. And it contains all the code you need to basically ship your CloudWatch logs to their service. This is what it would look like. You have to pick one log at a time, which is a bit laborious, but it's better than CloudWatch still. It's a very, very simple setup. You only actually need 2 things, which is a KMS encrypted customer token. So you get your customer token from Loggly, that's encrypted in KMS. And the Loggly host name, which one of our friends here knows, but I never remember it. But it's a fixed thing. The good part is it's only one Lambda. As you get new Lambdas, you can just add them in as triggers here and disable them at will as well. The only downside is you have to create all the dashboards yourself. You have to do all the integrations with the likes of OpsGenie and PagerDuty. There's no default setting for it. Something like New Relic and Datadog would have a one-up on these people, because they have all these pre-made stuff for you to do. So if you like making dashboards, use Loggly. IOPipe, my current favorite. It's coming out of Techstars. It's only in beta at the moment. We were looking after the invited into the beta. It is just an NPM package you install, and you wrap your Lambda in one of their own methods called IOPipe. It asynchronously, once your Lambda callback executes, it will asynchronously, non-blockingly, that's English, send details from your context object, which I discussed briefly earlier, to their service. The reason I like it is because these guys seem to spend a lot of time looking at Lambdas, and they have everything about every problem known to man, well, maybe that's an exaggeration, about Lambdas in their service right now. There's about 10 to 20 dashboards in there, I haven't counted them. So one, you see the blue line, that's how much my hello world Lambda takes up in memory. I don't know what the spike is, because I didn't spend enough time doing this screenshot. CPU usage is the same, so hello world does not use much CPU, which is good to know. There is like 20 more I could show you, but what's the point in that? Cost, I love the cost of Lambdas. So the calculation is very simple. It's time in milliseconds multiplied the amount of megabytes you've assigned to that Lambda. Default is 128. Don't ever give it 128, it's too small. By the number of times you call it. If you are lazy, there is a website for it called serverless.calc.com, and I threw in 10 million executions for 500 milliseconds with the maximum memory you can assign to a Lambda. And this is what I was telling my CTO. That cost us $12.70 last month, instead of hundreds of dollars on multiple servers that are load balanced out first. And that's if you're not in the free tier. If you're in the free tier, you get 1 million of these at the maximum megabytes, as far as I'm aware, or the maximum memory allowed. This is our actual build for Lambdas, and I found a bug in AWS, people. There was 24 cents they said they charged us for it, which is not real. And if, again, there's anyone from AWS here, I want my 24 cents. This is the section that I like the most, because it actually gives you the foibles of what we found out about using Lambdas and all the AWS services that go with it. We're going to try and tag team maybe a little, I don't know, because we did some of these slides, and I'm like, where did they come from today? So that's debugging. We found out it doesn't really exist. There's no way of doing a breakpoint and stepping through code at all. There is things you can do. You can do console.log. Yep, our emoji did not come out there. You can use the debug module, which Luciano is going to step in there very quickly because he won't put this in.
So very easily, given that you don't have the opportunity to breakpoint and step through your execution, what the solution we came up with to just debug crazy situations where you have, I don't know, functions doing calculations and all calling each other's, and then at some point you get the wrong value and you say, okay, where should I start to look for the bug? So what we came up with is using the debug module, the same that you normally use with Express. So probably we are already familiar with, which is let's say a bit more functional version of console log, because it allows you to enable specific logs, so you can put a lot of logs all around, and you can easily disable and enable them only when you want to see more details. And the thing works basically by assigning an environment variable called debug, and then you can put an expression. You can use even asterisk or many names, like get pending trade in this case. You can put a comma and add another function, and basically you can get the log only for that specific functions. So just to show you a very quick example, you import the debug module, and then the way you initialize it is just giving a name here at line 3, in this case get pending trade, and then at some point you would like to print what's the output of a specific calculation you are doing. Like in this case we are fetching products and we want to display the products in the log. We just do debug and products. Same story here, we want to show the formatted transaction by months. We just say debug this object. By default, nothing is going to be printed in your CloudWatch in this case, so you can log as much as you want. But then if you hit a bug and you know more or less what's the function that can be involved, you just write a new environment variable and you will start to see the log from the next execution. So that's basically it, and that's the best thing we could come up with. Still, it's not perfect, but better than nothing.
Key thing to take away is you should, if you want to use the serverless framework, its orchestration tool is CloudFormation, and you should learn it. There is in a YAML file again, everything is done through that file. There is a resource section where you can type in YAML for CloudFormation itself. So like they have a SAM model that you can just directly transplant back into the YAML file. And it just, it does get complicated in CloudFormation or the way the guys have implemented it. So this is what a hello world, Lambda, and API gateway looks like in CloudFormation. Who wants me to go through it in detail? Okay. I will not anyway. It is very, very difficult, so you should learn definitely CloudFormation. If you ever want to see what kind of CloudFormation stack is going to be created with your serverless package, you can actually do a SLS deploy, which is the command to deploy to wherever you want to deploy to, and then you can go no deploy. So what it'll do is it will create a dot file called serverless, or dot directory called serverless, and if you go into it, that's your Lambda zipped up. This is the create stack. Don't have to read that. It's just an S3 bucket where it's going to put this zip file, and then the update stack, which contains JSON in this case because they haven't updated the YAML yet, but it contains JSON that will describe your stack. CloudFormation is interesting. It has a limit, and hopefully we'll remember to say that when I go through the limit section and what that limit is. API gateway is like any other API gateway, except there is no automation if you have a custom domain. It is a manual step, so every time you do a new Lambda that requires an endpoint in HTTP, you have to go into your console and actually set it up manually. There is a possibility to do it through CloudFormation. I just haven't figured it out yet because it's difficult from the last slide. API gateway, you used to have only 10 seconds. You now have 30 seconds for your Lambda to execute. So there's a limit on the amount of time a Lambda can execute for, but there's a shorter limit on if you're doing a request through API gateway, and it will just give you a request timeout, which makes you think, did my Lambda just timeout for some other reason like connecting to a database? So that sucks. Limitations on Lambda. So for temp space, you do have access to /temp, you put only 512 megabytes of it. Lambdas can only execute for 300 seconds. If you're doing a request response through the SDK, your payload side is only 6 megs going in, and these are all hard limits, by the way, because I admit that you cannot bring up Amazon and go up it. They won't do it. They can't do it. If you're going through an event, it's 128 KB, which is savagely small, or massively large, depending on what you're doing. And the maximum deployable package or zip file that you can upload to Lambda is 50 megabytes. This is why Luciano went away and figured out how to do tree shaking. Because we had situations where we were deploying these massive packages up to Lambda, and it was just saying, sorry, can't do it, and you cannot cheat it.
The funny story is that if you use the AWS SDK, you already get very close to that limit. So you cannot use anything else unless you have tree shaking or other kind of things to reduce your code.
Soft limits. So there's a URL in this one. We'll share this with you after. Go to this URL. It'll take about 2 hours to read it. And it goes through every default limit that for every AWS service out there, and there are lots. You get 100 S3 buckets by default. So if you're deploying a new Lambda, it will create an S3 bucket through serverless. You do 100, done. And it takes about 2 days for these guys to respond back to you. So if you're doing something mission critical, you'll have to wait 2 days, unless you pay for it. There is 100 concurrent Lambda executions at a time. There is 2 API calls to CloudFormation at a time, and it works serially, not in parallel. Go to the URL, it's interesting reading. Most of the stuff, or all of the stuff can be lifted. You just have to send an email to their help desk, and they'll do it for you in 2 days. This is the only real problem I see with Lambdas, and it's one that everyone talks about. We're missing our emoji again. Fail. Cold starts. So cold starts basically means that from the time you have deployed Lambda and executed for the first time, the amount of time it takes to spin up that container initially before it starts executing your actual function is called a cold start. it can range from anywhere from 3 or 4 seconds to 200 or 300 seconds, depending on how bad it is. There seems to be there's a lot of old wives' tales out there apparently about add more memory, it'll do it faster. It doesn't help. There's a great blog post by a guy we'll mention later on called Mammino who's done it, and it's like, doesn't work. Every old wives' tale you've tried to do max everything out, doesn't work. It's just the nature of Lambdas. Tim Wagner wrote a blog post about it, the container reuse thing. IO Pipe, the guys we use for monitoring, have a really interesting post about it, where they measure how often a cold start actually happens. And people are saying, oh, it's about 3 hours, and they measured it's about 8 hours, except on one day when it was 16 hours, and nobody knows why. So whatever AWS did, they extended it for one day and then stopped doing it. So serverless beer is the thing. This is actually Casillo Zen. He's a Brazilian or Portuguese. I think he's Brazilian, and he has this really good tutorial if you ever want to get started on serverless. It goes through every service, CloudFormation, Dynamo, don't use Dynamo, Lambda's API gateway, creating a React app, deploying it to an S3 bucket. These beers are not real, unfortunately, but it is a really, really good tutorial. I'd recommend anyone who wants to get started, go to Cassie's website to do it. So to recap.
So at this stage we just want to have some takeovers from this talk. So our idea is that all these serverless architecture and the serverless framework are really, really cool technologies, because first of all you have almost infinite scalability at very low cost, and you saw how much we pay at this stage. And also is everything managed for you, so you don't need to worry about having servers or getting calls at 2 AM at night. So the issue is that there are still some limitations, so you can get started very easily, but as soon as your architecture gets complex, you will hit some walls and you need to figure out your own solution. So managing a project that is getting bigger and bigger, complex and complex, can be hard, but at the same time we are seeing that there is a lot of effort on the community side to get things smoother. So we really believe that the developer experience is going to be improved in the following years. So we will say it's definitely a technology and architectural approach to invest on for the future. Go ahead with the team.
So this is our last slide, and we're only recapping on stuff that all of us have learned in the last couple of months. This being all, we do not have V for Vendetta working for us. There is an open position in our company for another software engineer who wants to come and do really cool stuff with us, learn about electricity. Turns lights on. Notable mentions are, we have this guy Joe. He's not here tonight. He works from Cork mainly. He's written Loki.js. It's I think one of the most starred projects in Ireland. It's like MongoDB for mobile clients. It's the way I sell it anyway. We have Joe, who's here somewhere. Stick hand up, Joe. Gus. Sorry, too many Italians working there. Gus, he's our product owner. He comes from Paddy Power. He's probably one of the best product owners we have, or the city has, in my opinion. We have Luciano, who's written his own book. It's really cool. Buy it. I get a referral fee.
Thank you.
No problem. So I give you the plug. So that's 3 Italians. Don't read into that too much. And thank you.
Is there any questions?
Don't be shy.
Yeah. Any questions?
You showed us a kind of diagram in the second lesson learned, and I did not understand anything. Can you explain with other, just in a nutshell?
I didn't include the legends, so probably not. But what it does measure over time is when a method was called, the amount of time it took to execute, or start executing the method or the code in the Lambda. So there's the bottom one and then the top one, and it goes all over the place. So you can see it took up to 30 seconds to do this guy over here to invoke the actual function code that exists in the Lambda from the time it was actually asked by Lambda. Does that make sense?
Just to make a realistic example, assume that you have an API built on API gateway with a Lambda behind. Most of the time you're going to call this API and it's going to respond in milliseconds, let's say 10 milliseconds. But at some point it's going to respond you in something variable from 1 to 9 seconds, which of course is really bad for the performance of your application. So, and the issue is that you don't know when this is going to happen. And this diagram tries to explain, like, okay, this is happening once every some hours. So still it's a big problem that we are trying to find a solution for.
Luciano does have a good solution, which is you ping the Lambda every couple of hours, just like, you know, are you alive? It will incur a cost over time, but it'll be like 3 extra lines of code for every Lambda, like we have with the ACL one. We like, are you alive? Yes. So the container stays up all the time, which does defeat, I know, Lambdas a little, because you only want them to execute when you want them, but if you want to have a responsive Lambda, that's what you'd have to actually do that for.
Other questions?
I know you say that the serverless thing really works for you guys, but have you ever been tempted with any of these problems and the things, the workarounds they have to do to just like, let's have a server somewhere and run Node all the time?
I think you should.
No.
Never been tempted?
Yeah, well, of course. There's like a lot of stuff around data as well. Like, you know, they tell you use DynamoDB in every tutorial going, we don't use Dynamo. We do use RDS, which is still mostly managed. Scaling would still require like DBA type work to make it go, but it is mostly managed. We use Redshift, I won't say what I should call it, for doing transactional stuff, which is a wrong way to use it as well. So we would never say no to a server. We just need a good reason to do it. Like, we have a Rundeck server. It's the only server we have, because we can't find a hosted service on it. It's just impossible. You told me it was impossible.
Steve.
Yeah, still. So tempted, yes, but, you know, compelling use case. I don't want to get called out at 2 o'clock in the morning is one of our use cases. So no server, make sure that doesn't happen.
Perfect, cheers. Hi, just a question, like how much rework would you need to do if you wanted to move to another provider? Like, for example, the Lambda from AWS, you have these events that you're receiving. Are other providers having similar solution? Like, is there a lot of work to move to, let's say, Azure or Google, for example?
Okay, that's a very interesting question. I will try to respond as best as I can. But I have a very short answer, that Amazon is everything about locking you in as a customer. That it applies for everything you do with Amazon, not just Lambda. So basically, I think the cost to switch to another provider is going to be very high, which means mostly rewriting everything. But at the same time, I see something in the serverless framework that they are trying to find this kind of abstraction layer, where probably if you use just some of the basic functionalities, can be very easier to switch from one provider to another, at least for a single functionality, like a very specific Lambda, doing maybe just some calculation, not using, I don't know, databases or S3 or other resources from AWS. I don't know if this is a good answer to your question. Thank you, everybody again.